Hey there, in this video we're going to take a look at some nonlinear and non-quadratic function graphs and equations, and we aren't necessarily going to see these examples in depth, but we are going to want to make sure that we can recognize that these are specifically nonlinear and non-quadratic, so that if we were looking at a problem where I give you a graph of a quadratic, and there are some answer choices over here for equations that go with it, you're able to differentiate between a quadratic graph and a quadratic equation versus an exponential equation or cubic or something that's non-quadratic and nonlinear, so that we know, oh, hey, that one doesn't match this graph because it's not a quadratic equation. Or if I give you a line and I give you some equation answers, you are able to say, oh, well, that's not a linear equation, that is a cubic or something else, so that's not going to make that graph. So that's what we're going to be looking at today. Again, these are, in this example or this lesson, these are functions that you are not going to need to know in depth. It's more just being able to recognize that they are nonlinear and non-quadratic. And then getting into some of these, you'll see the word parent function on some of them. That's just the most basic version of an equation for that given function. So for example, you'll see one that's y equals x cubed. That's a parent function of a cubic graph. And that's just the most basic version. There's not addition or subtraction or multiplication tacked on. It's just the very basic equation for that. So the first one we're going to look at is the square root function. So with square root functions, the parent function looks like this. The key thing we see is that square root symbol. So we have an x under the square root. It could have plus a number, it could have minus a number, it could have a coefficient in front of the root. There's so many other things that it could have, but this is the most basic version, and it is going to have that square root symbol with an x underneath somewhere to be a square root function. So graphically, if you see a graph, let's say I give you an equation and there are some multiple choice options for which graph matches that equation. If you see one of these are not linear and they are not quadratic. And so you shouldn't choose one of these as an answer. You'll notice some characteristics of the graph that make it square root. One of those is that every single one of these is a sideways parabola cut in half. So if I were to take a parabola and I were to cut it in half, the square root function is either the top half of that or the bottom half of that. It's not going to be both, but it will be the top or the bottom half. So you can see that here. It is the top half of a sideways parabola. We've got the bottom half of a sideways parabola. This one is a sideways parabola going this direction, and it is the top half of that. That's what this third graph is. So it is curved. It's not a line, so it is not a straight line coming off of that. It is actually a curved graph, and it has an endpoint on each of them, and then it goes in the other direction forever. So technically those would continue on, but they do have one endpoint on each graph. Then we have exponential graphs. So with exponential graphs, I give you a couple examples of those because technically the parent function, you probably say this is the parent function, but to not get into the weeds too much, the base here, the 2 or the 5, could be any number that's positive. So with that being said, if we have a different base, that doesn't really matter. The key thing is that the x is in the exponent. So the x is the exponent. That is what makes it exponential. And so that's not going to be quadratic, where it has an exponent of 2 is the highest, and it's not going to be linear, where the 1 is the highest exponent. The x is the exponent, which makes it different. So we have a J or an L shape, depending on how you look at it and what way it's reflected. It is always a curved graph, and it has something called an asymptote, which is that dashed line in each of these. And that graph gets really, really close to the asymptote. It even looks like it touches it because of how zoomed out this is. But if I had the capability of zooming in these places where it looks like it's touching that gray dashed line, you would find that it is not actually hitting there. So that's some key things about exponentials. They have an asymptote, which is that dashed line, and it's going to make either that J shape or L shape or a reverse or reflection of one of those. Another type of nonlinear non-quadratic would be a cubic function. So this is the parent function of a cubic graph. F of x equals x cubed, so it is a third power, whereas quadratics are squared, and linear is an x. So this is also curved. There are no sharp terms. There's only smooth and continuous curves. So we can see that in each of these, while they look different, they do create a curved shape in any of them. Another one is a piecewise function. So piecewise looks a little bit different. So we can see that there's actually 3 examples of some equations here. And they look a little bit different. They have pieces or parts, so they have multiple lines to them. And they look that way in the graph as well. They're cut into portions or pieces. So you can see we have a line here and we have a curve here. Or we have part of a parabola here, and then we've got a line over here. We have a line, kind of looks like half of a circle here, and then another line. So it's made up of a lot of different parts. It can be linear pieces, they can be curved pieces, it can be a mixture of the two. It could just be only linear. So maybe it looks like that, where we have lines put together and they're not curved, but they're straight lines maybe. They could be broken up. So it could be like this and then this on the same graph. So there's a lot of different ways that piecewise can look, but oftentimes we see jumps, we see breaks, we see sharp turns or corners there, and different shapes that make up those graphs. So that again is a piecewise function. And just a note, with the piecewise function, it can have linear or quadratic within it, but it doesn't have to. It could be made up of other things, like for example, we see the square root here, or we might just see the x cubed, for example, over here, or things like that. So it can have linear and it can have quadratic, but it can also be made up of other things. But as a whole, it is not linear or quadratic. Nonlinear curved functions are polynomial functions. So with these, the cubic actually does fit into this category, but this category is even broader than the cubic example because it has higher degrees. So 4th power, 5th power, I gave you an example of a 7th power, could go even more than that. But polynomial functions are going to be just like the cubic graph, going to be curved. They're going to be smooth and continuous. They won't have breaks or jumps like we saw in the piecewise functions. Some others you might see as distractor answers. For example, this one here is a sine graph. So this is a sine function. That's one of our trigonometric functions. We'll talk about in a minute the tangent graph as well, but with sine, you could see potentially a cosine graph as well, which really resembles a similar shape to this. This is called an oscillating curve, so it just goes up and down over and over again between the same range from top to bottom. All right, and it's again making the same waves here as it continues. And then we have our tangent functions. Again, this is another trigonometric function. It is a repeated curve. So again, we see it almost looks like a cubic in a way. It looks similar to that cubic shape that we saw. But there are vertical asymptotes, meaning that it just repeats. But as it repeats and it gets closer and closer to these dashed lines, it's not actually going to touch that, just like the exponential graph. But the exponential one had a horizontal asymptote, and it was approaching that horizontal asymptote like this. That was our exponential graph. So with a tangent function, again, it's just noticing that it is not linear, it is not quadratic, it is just going between vertical asymptotes like this. And a cotangent function is going to look similar to that. And again, that would look like this in terms of the equation. It will resemble a similar shape, typically just going the opposite direction. So in summary, we've looked at some different types. Again, you do not need to know these in depth at all. All you need to know is that if you were to see these on a problem where I give you a quadratic graph or I give you a linear graph and you're choosing an equation that goes with it, or vice versa, I give you an equation for a linear or quadratic and you're choosing the correct graph, you just need to recognize that the quadratic is going to be that parabola shape, the linear is going to be that line. For equations, For parabolas, you're going to see x squared as the highest exponent. For linear, you're going to see x as the highest exponent, and you're not going to see those additional functions, those square root or being raised to the x power or something cubed. Piecewise is going to be written in a somewhat funky way with this bracket, and they're going to have different parts to it or pieces to it. Polynomials include the cubic functions, but they're going to have maybe x to the 4th or x to the 12th or x to some other power higher than an x squared or an x. Sine function is just sine of x, and tangent is tangent of x. And again, none of those are the parabola or linear shape. The only one that sometimes can trick people easily is that piecewise. That piecewise is not going to be linear or quadratic as a whole if it's broken up into those pieces like that and doesn't just look like a single parabola or a single line. So just keep that in mind. Piecewise can be made up of linear and quadratic, and that can throw somebody off. But we've talked about what our quadratic graphs and equations look like and what our linear graphs and equations look like. These are just going to be oftentimes our distractors, so you want to make sure that you don't let it distract you.